we're going to check to see if we can find the critical numbers of this function. First, remember, we don't need to know what the function looks like, the visual. We're building up to the point where we're going to start to study what a function looks like without the use of a graphing tool to help us. Old school, we might say, one of the uses of calculus before the current technology gave us other ways to look at it. So this particular function, this rational function, has no undefined values. The denominator will never be 0 for any real value of x we plug in. If x is 0, we get 0 over 5, which is 0, no problem there. If you put in a negative value for x and square it, it'll be positive. The denominator will never be 0. So I'm just going to put a little note here. There are no undefined values for f. Remember the definition of a critical number. When we take our derivative, the foundation of the definition is that it's a critical number. It has to be a point on the graph. So this has no undefined values. So now we're going to find the derivative. The first derivative of this function, I'm going to use the quotient rule, and the lower function, sometimes called g of x in the Western world, is going to lead things off, multiplied by the derivative of the upper function, sometimes called f of x. It can't be because this is f of x. So derivative of x squared is 2x, minus, or subtract, the upper function x squared multiplied by the derivative of the lower function, which is also 2x. And this is the numerator of our derivative. The denominator is this original function in the denominator quantity squared. Just a little backup observation. No undefined values again. Alright, so where this says we don't have anything undefined in the function, we're not going to be dividing by 0 here. There are no undefined values for the derivative either. And let's do a little bit more work here. The derivative is 2x cubed plus 10x minus 2x cubed. That's very convenient. X squared plus 5 quantity squared is the denominator. And we end up with our goal to find where any critical values are. Is there a place that's defined on the function that's undefined in the derivative? Well, no. But is there a place that's defined on the function where this derivative is equal to 0? And in my classroom, we've sort of repeated this a fair number of times now. A fraction is equal to 0 when the numerator is 0. So we end up looking at when does 10x become 0? And that happens when x is 0. There are no other critical values for this particular given function. So this is, I'm just going to write only here so it's clear that I'm stating that there aren't any others that got lost in my algebra. There you have it. The critical number of a very lovely rational function. Until next time.